All right, so we've been looking a lot at our structure of our atoms. And so we've been looking at protons, electrons, and neutrons. Protons, neutrons, they're easy. They're in the nucleus. We know that. They're right there in the middle. The electrons get a little more complicated. So we're saying they're whipping around in the outside. Well, we need to be a little more specific because these are actually what start to form our chemical bonds, are these outer electrons. And so it's really important that we have a good working understanding where we're most likely going to find those electrons. We call that the electron configuration. A couple of caveats here, a couple of things to consider. One, this is going to feel a little nebulous until we get all of the parts. So there's some pieces we need to understand and kind of have before we can kind of come back and put it all together. And two, this is fairly conceptual. A lot of this is actually dealing with our quantum physics and our quantum probabilities. And so this is a little weird to start thinking about. Now, the good news is there's very much a pattern. So once we kind of see the pieces, we put it all together and we catch the pattern, we're going to be great. I've been doing this a long time. I promise we'll be successful. But it does mean that you've got to be paying attention because this is going to be new, I'm willing to bet, for all of us. So taking a step back, we're trying to figure out where we're most likely going to find the electrons. Well, we can relate that to you, right? If I want to know where I'm most likely going to find you, if I want to send you something or come and give you a package or a delivery, I would need to know your most probable location, which we use as our address. And so just like our address has 4 parts, so too does our electron configuration. So if you look at a standard address, and so here I've got just, we've got our Liberty High School address. Sorry, I've got, sorry, I didn't mean to freeze my picture in there, sorry. Here we've got our Liberty High School address. There's kind of 4 parts. The least specific part, the least specific information is very much that state. If I told you I'm somewhere in the state of Missouri, come find me. Well, you could maybe do it. It'd take a really long time though, right? If we want to zoom in a little bit further, our city and zip code go together. We kind of zoom in from the state level down to the city level. Then we get to the point where we're on the street. If I told you I was on Blue Jay Drive, well, theoretically, you could start going door to door, oh, Mr. Jorgensen, right? Start yelling. And if you have then your final piece, your house number, you have only one option, one opportunity. And so for a standard address, there are 4 parts: the street, the house number, the city, and the state. And just like there's 4 parts to our address, there are also 4 parts to our electron address. Our electron address has 4 pieces, and that's really what this is. We're talking about our most probable location to find our electron. And this is all based on charges, right? We know those electrons are negative and they're being held or attracted to the positive protons. So we're going to try to put them as close to the protons as we can without getting them around other electrons. And so our 4 parts are going to be the energy level, the sublevel, the orbital, and the spin. And if we're thinking about our analogy, our energy level, that would be the state. Ooh, let me spell here. The state. Okay, let me try that again. That would be the state level. This is the broadest or most general piece of information. We zoom in then to our city, which is our sublevel. Well, that makes sense. Sublevels are going to be within the levels. And within our city, we then get to our orbitals, what we call our orbital shapes. This would be our street. And then the spin, that would be our house number. So again, just like our address, there are 4 addresses that we start to see for our electron configurations. Cool. Now we got to define these, talk about how we kind of quantify these relationships. And then we're going to come back and put it all together. Energy levels. So the easiest way to kind of identify where our electron might be at is in energy levels. And these just represent kind of the rings, the general rings around, or the distance from the nucleus. So as these numbers, they're whole numbers, so n equals 1, n equals 2, n equals 3, as these numbers get bigger, as they get larger, that means we're further away from the nucleus. We're further removed. It also, that means if we're further away, describes the size of our electron cloud, how large our atom is. As the energy levels get bigger, so too does our atom. If we want to know how many electrons will fit in that cloud, there is actually a mathematical value or a mathematical equation. It is 2n squared, where n is the energy level. And then when you plug that in, we actually end up getting the total number of electrons that you can fit in there. So 2n squared. So if we're, for example, in the third energy level, 3 squared is 9 times 2 is 18. In the third energy level, you can fit a maximum of 18 electrons. And then it's full. And then you'd have to put more electrons somewhere else. Cool. So again, I'm going through the parts kind of fast here. Feel free to pause, get down your notes, and then kind of continue on with our examples here. But again, kind of the broadest sense of information, it's going to be our energy level. Just how far are we from the nucleus? Within each of those energy levels are the sub-levels. So we're going to take those energy levels and we're going to split it down a little bit. We're going to be a little more specific as to which electrons we're talking about. So these are found within each of our sub-levels. Within each of our energy levels, excuse me. In each energy level, you can have as many sub-levels as your energy level. So in the first energy level, you can only have one of them. In the second energy level, with more space further out, right? In the second energy level, you can have 2 sub-levels. In the third energy level, you can have 3 sub-levels. In the fourth, you can have 4 sub-levels. In the fifth, you can have 4 sub-levels. Oh, wait a minute. Oh, that's because there are 4 sub-levels. They're identified with letters. It is S, P, D, and F are the 4 sub-levels that you can have within an energy level. So once you hit the 4th energy level and beyond, for any ground state atom, non-excited, we'll talk about that later, you're going to either be S, P, D, or F for your sub-levels. And you can only have as many as you have space in your energy level. So for example, in the first energy level, you just have 1 sphere. In the second energy level, sorry, 1s sub-level. In the second energy level, you can have an S and a P. In the third energy level, you can have an S, P, and D. In the fourth energy level, you can have S, P, D, and F. And so this is, again, we're just subdividing, kind of breaking down our energy level to make more kind of smaller pieces, just like our cities do within our states. Within each of these kind of sublevels, there's a max number of electrons you can hold. Our S sublevel can only hold 2 electrons or a pair. Our P can hold 3 pairs or 6 electrons. Our D sublevel can hold 5 pairs of electrons or a total of 10. And our F, if you're seeing the pattern, it's our first 4 odd pairs. Our F sublevel can hold a total of 7 pairs of electrons. That would be 14 electrons total. And so we're just kind of subdividing. So for example, in the second energy level, second kind of shell, if you will, you'd have an S and a P sublevel. In the second energy level, if we think about a formula, 2n squared, so 2 squared is 4 times 2 is 8. 8 electrons total in the second energy level. We can put 2 of them in the S. The other 6 go in the P sublevel. And so we're just kind of splitting them out into smaller chunks. Now, this isn't really precise. It's not 1 electron location. We're zooming in on it, but we're kind of slowly but surely nibbling in or kind of zooming in on our final location. If we have all 4 of our parts, it's only 1 electron, 1 house for our example if we're thinking about it. Cool. So we have the state in the energy level, the street for our sublevel, and then we've got our orbitals. Our orbitals represent the shapes, the actual physical shapes around the nucleus where our electrons start to hang out. And these orbitals come in pairs. Those are synonymous for us. This is the space where a pair of electrons are actually going to live, or we're going to find them around the nucleus. And this is where we're most likely going to find them. And again, at any point in time, they might be anywhere in that shape or in that space, but these are the areas where we're most likely going to find it. And technically it's 95% of the time, but don't worry about that. Oh, those letters come back. The S sublevel, well, that makes a sphere. You have 1 sphere in that S sublevel. In the P sublevel, you've got 3 of these orbitals. It's 6 total electrons in the P sublevel, so that would be 3 pairs of electrons. And that's going to be, they're going to occupy peanuts. One peanut's going to go up and down, one's going to go left and right, one's going to go front to back, 3 dimensions, right? Each one of those containing a pair of electrons. So 6, so we've got 2, 4, and 6 electrons as we're going across. In the D sublevel, we call those our double peanuts. They kind of have 4 lobes on them. And then for our F sublevel, F so-called because the the actual three-dimensional space they make is what we call a flower. And I'll show you an example when we get back together. That one looks kind of funny. It's hard to draw. So again, we're just talking, here's the region where we're going to find these electrons. Don't worry, we're getting all the parts. Come back and layer it in. So we've got energy level, sublevel, orbital, which is pairs. We're down to two electrons in our orbital. And finally, we get to our spin. The last difference, or the last part of our address for electrons, is the spin. Each orbital can hold 2 electrons, or a pair of electrons. Now we need to know which one is which. The way we tell them apart is with their spin. Electrons in an orbital have to have opposite spins. One's going to be clockwise, the other will be counterclockwise. We can't tell which is which. We just know that they have to be one and the other. So usually by convention, we say we do the clockwise first and then the counterclockwise. But if you know all of these things, if you know all 4 of these parts, if you know the energy level, the sublevel, the orbital, and the spin, there's only one electron we can be talking about. That's the final address for our electron. Cool. It's a lot of pieces. Let me kind of take you through an example here and kind of help you think about what we mean when we're starting to say our electron configurations. So for example, if we think about our nucleus, I want to put a little nucleus way over here. In the first energy level, we always start closest to the nucleus because we're going to have our positives attracting our negatives closer to them. So the first 2 electrons always feel as close to the nucleus as possible. So this would be, if we're just thinking about kind of our, I'm gonna just draw right on my face, look at that. If we're just thinking about kind of our energy level, that's our broadest term, we would say that this is energy level 1, energy level 2, energy level 3, energy level 4. So we're just, as we get further from the nucleus, we have increased the distance, we've got larger space, and they're going to be able to hold more electrons. In the first energy level, you can only hold 2 electrons. That's the 2n squared again, remember? In the second energy level, we can have a total of 8 electrons. In the third energy level, we can have 18 electrons. 4 squared, 4 times 4 is 16 times 2 is 32 electrons in the fourth energy level, and so on and so on. You can go further than 4. We're just going to stick with 4 for now for space purposes. And this is like a snapshot, right? These rings would go all the way around. If we had a full sphere, we're just kind of looking at one piece of it as we're looking at our atom. There'd be more on the other side of our screen. So in the first energy level, so right now we're in the first energy level. If I told you there's an electron in there, it could be one of 2, right? If I told you there was an electron in the third energy level, it could be one of 18. So we need to be more specific. We got to kind of dial in on that address. So from energy level, we go to sub-level. In each energy level, you can have as many sub-levels as your energy level allows. In the first energy level, you can only have 1 sub-level. We would call this the 1s sub-level. In the second energy level, you can have 2. You'd have a 2s and a 2p. The big number here just tells us which energy level we're on. The letter tells us which sub-level we're in. In third, we can have a 3s, a 3p, and a 3d. And in the fourth, I want to make sure I have room. I got 4s, 4p, 4d, and 4f. 4f. So we're just splitting apart our energy levels, being a little more specific. Sometimes we'll actually show how many electrons are in there. So we can have 2 in the s's. S's all hold 2 electrons. Our p's can hold 6, and that makes sense. In the second energy level, we can have 8 total electrons. 2 of them are in the s, 6 of them are in the p. So p's hold 6. D's then, okay, I got 2 and 6 is 8. That means our D's must hold 10 electrons. And let me zoom in, see if I can get it in there. Our F's hold, oh, couldn't do it. Sorry. Our F's hold 14 total electrons. 14 total electrons. Cool. So again, we're just trying to narrow in, trying to drill into which electron is which. So now if I told you, okay, that electron in the third energy level, well, it's in the p sublevel. Okay, well now it's 1 of 6. I've narrowed it down. It was 1 of 18. Now we're down to 1 of 6, but we need to be more specific. If I were to split that down further, I know that my p sublevel has 3 pairs, 3 orbitals. 1 peanut going side to side, 1 up and down, and 1's kind of hard to see three-dimensionally, front to back. So oftentimes we don't draw all these shapes. It's kind of goofy when you start to look at it. So sometimes we just draw lines. We'd say, here's our 3 p orbitals. So this first one then, let's see if I can get my pointer. I want my pointer back. Oh, nope, I didn't want that. Okay, resume. If we're looking at our peanuts here, so these lines represent our different peanuts, our different p orbitals. And so what we'll usually do is we'll show that with, no, hit the wrong button again, sorry, with arrows. Boop, 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 boop. Let me finish my arrows here real quick. Cool. So now if I told you that that electron was in the, I don't know, up and down peanut, sure, why not? Well, I know it's in the middle orbital. It's more specific. It's now one of two. But if I told you then that it is the clockwise spinning electron, I now know exactly which electron I'm looking at. And I promise we're going to be doing a bunch of practice for this, making sure that we understand we're going to do lots of these. So please do not fret. We're just saying where we're most likely to find our electrons. So here we've got our up arrow. So it's the clockwise spinning electron in the second orbital, or the second peanut, in the p sublevel, and the third energy level. If you have all four of those address locations, there can only be one electron we are talking about. So this is how we start to describe our electrons. I know it seems a little convoluted, but this is how we are marrying together how we can count and kind of identify the number of electrons and their attraction to the nucleus. And so if we wanted to look at a more real world example here, let me pull up real quick. I want to screen share. Oh, not that. Ooh, nope, not that. Oh my goodness. Come on, tech, you can do it. Come on, technology, you can do it. Real quick, let me pull up our YouTube video. So here we've got our scandium. So scandium, if you look on the periodic table, scandium Sc is number 21. We're going to assume it's neutral. So it's got 21 protons. It's going to have 21 electrons. And we want to say, where are we going to find these 21 electrons? Well, the first two electrons are going to go in the first energy level. So the first energy level, that's the one here. There's only one sublevel, it's the S. It makes the shape of a sphere, and in that sphere we can put 2 electrons. So we're up to 2 electrons. And that's gonna go closest to the nucleus. It's got an energy level of 1, gonna go right there in the middle. First energy level is full now. That's all the space we got. So now we're gonna go to the second energy level. And the second energy level, we're further out. And now we start again with the S. There's 2s, and we can fit 2 electrons in there. It's further out. If our nucleus was right here in the middle, our next 2 electrons go further out from there. After 2s is full, then we're going to go to 2p, and you'll notice how it kind of nestles in around our original now 4 electrons. So the red here representing where we're most likely going to find those electrons. And so here we've got kind of the side-to-side peanut. This represents 2 electrons, and it's kind of like the nesting dolls, the Russian kind of babushka dolls. That we're going to kind of fit it as best we can in 3-dimensional space all around our nucleus. Now in here we've got 2 electrons, so 2 in this peanut. We'd have 2 more in our next peanut going front to back here. Notice that's the same size, it's the same shape, it's the same distance from the nucleus. And then our third peanut. So here's our 3 peanuts of our 2p sublevel. Again, it's quantifiably, we're trying to get our electrons as far away from everybody else, but as close to the nucleus as we can get it. Second energy level, we had 2s and 2p. It's full now. So now our next electrons have to go in the third energy level. So S again, but a bit bigger. We're further out from the nucleus. So 2 electrons go into that sphere. Oh, we're going to have 3 new peanuts, bigger, further out, third energy level, but we'd have 2 in this one. 2 in our PY, don't worry about the PY part, but 2 in this peanut. And then another 2 electrons in our top and bottom peanut. And now we're to we're in a weird zone. We'll talk more about this, but we actually end up filling the 4s first, and then we go back to our 3D. We'll talk about that in class, but so there's 2 in that, kind of that 4s2, and then we need 1 more electron that goes in that d orbital around our nucleus. And so we're talking about, and again, I know there's a lot we're throwing at you right here. Just if you've got the notes and have those pieces, we'll put it all together when you come back to see me. But we're talking about where we're going to find the electrons and how can we maximize their locations around the nucleus. Cool. Make sure you've got the notes. We'll come back and we'll talk about all these pieces. I just want to make sure you have all of the pieces so that we can kind of come back and start to look at some examples. Awesome. Thanks, guys.